Hi. I got a little thing for math nerds, so if you're not a math nerd, just totally change the channel, go watch another video. This is about this equation right here, which actually can't exist when the number p over here is bigger than 2. It works great for 2, it defines circles, it's a nice little useful thing, if you ever wanted to create a circle, and say you want the radius to be whatever number, plug it into a computer, x squared plus y squared equals your radius of your circle, and it will draw it and graph it out, and hey, awesome. So, the thing is people often wonder, well, how come this doesn't work for stuff bigger than 2? Well, we can go ahead and show you that right now. Alright, we're going to start off with, we're going to try and construct that, some usable version of that equation. So this is a big mess over here. We'll start at the top and say, we're going to pick a z where z equals x plus 1. And then the full explanation, you have to use x plus n to cover all possible cases. If you do that, in order to fit in our equation, our n will then have constraints, like it can't be bigger than y, because otherwise it'll screw up us trying to make that equation. So n is going to have to be less than y, but of course bigger than 0, because otherwise, who cares? So anyway, I'm just going to use x plus 1 to start off with, so that you see how easy it is. And I don't know if you're familiar with Pascal's triangle. This is something that comes in very useful when you're doing, I believe it's called binomial expansion. I'm trying to remember crap from high school, so who knows. But I could be wrong. But anyway, what this allows you to do, this graph is like a cheat sheet. You construct it by, so you start with 1, so this is like your first row of 3 ones. And then you start adding and adding, you add these 2 1s together to get this 2. Add some 1s on the side, because we're building a Christmas tree. 1 plus 2 is 3, 2 plus 1 is 3, you fill that in, So anyway, high school geometry teachers can explain this much better than I can. But basically there's some neat factoids about using these numbers in these rows, for if you're saying x plus 1 to the 7th power, you would cheat by using the numbers off of these rows. And it shows up here when I try and cube z, which I said equals x plus 1. I'm going to use the 3rd row because I'm cubing. So my x plus 1 cubed ends up with, 1 times x to the 3rd plus 3 times x squared plus 3x plus 1. Fantastic. Now, in order to get it to look like that equation, with 3's where the p is supposed to be, we have a z equals x. Hey, great. Does this stuff right here, could this possibly look like a y cubed ever in, the world of numbers? So, over here we're going to use a simple substitution, because in order for this equation to work, well, we know that x, y, and z kind of have to be bigger than 1, and if you can't see that that's obvious, then this might be, you might not want to bother watching anymore either. Anyway, x, y, and z have to be bigger than 1. It's you can just do some math and prove that. So anyway, that being the case, if y is bigger than 1, we can replace y with any possible number we want, plus 1. So, we will do that and end up with, anything that is y cubed, any possible value, would have to fit this formula, would have to take on this shape of a cubed plus 3a squared plus 3a plus 1. Easy. If this is supposed to be y cubed, and we know this is y cubed, well, let's see if they're equal. So we set them equal to each other, the ones nicely cancel themselves out and go away, and we end up with this bloody little mess. Breaking this stuff down, we end up with 3 times x plus 1. And that's this part right here, factored out, equals something cubed, a cubed, plus 3 times a plus 1. Whoa, it looks exactly like that. This could pose to be a problem because we're missing, oh, my question marks look like a happy face. Anyway, we're missing a corresponding value over here, so we know that x is not equal to a, And besides, it shouldn't be. X should be bigger than Y, and Y is bigger than A. Since we're picking X to be just one less than Z, obviously Y has to be a lot smaller. So anyway, looking at it all that way, where was I up here? There's another way we can write this equation which factor out the common A and say, you know, this is this plus that. Well, so let's look at what are the possible factors of this thing. The A squared plus 3A plus 3. If we start throwing numbers into that equation, we're going to find that it spits out prime numbers. If you throw in a 0, it spits out a 3. If you throw in a 1, it spits out a 7. And if you throw in stuff that's divisible by 3, well, it's going to throw out stuff that's divisible by 3 because of that. Point being, this thing generates primes, so obviously it can't be factorable because primes don't have factors. So this can't be broken down into any smaller of a number. Its factors are pretty much going to be one in itself as far as this equation goes. So, A, also we don't know what the factors of A are, but let's go over here to see if we can get a clue. On this side of the equation we know 3 times x plus 1. Now x and x plus 1 are what is called relatively prime, because they're numbers that are right next to each other on the number scale. They don't have any common factors. It's just another one of those things they taught me in high school geometry class. Great teachers. Anyway, so yeah, I remember all this stuff. So yeah, the fact that these things are relatively prime basically tells you, you know, the other thing that they'll teach you is, you know, you got an A in here, you got an A in here. Obviously, one of these, if not all of them, divide into this thing, which we know that this thing can't be factored because it spits out prime numbers. And, you know, even though 3 is a prime number, x and x plus 1 can't possibly be, because the only ones that are consecutive are 2 and 3. Because after that, every other number is divisible by 2. So one of these numbers is divisible by 2. So they can't both be like, you know. Anyway. The point of the story is, x plus 1 is z. A is supposed to be tinier than z. How the heck can we say, you know, a divided by z equals something when a is smaller? It's going to be a fraction, but we're looking for whole number answers here. So, anyway, a has to be smaller than z, so it can't get in there. And in fact, we already established that with x being so close to z, a has to be smaller than y, which is smaller than x. Therefore, this equation is completely unsolvable. Well, what does that tell us? There's something wrong on one side of the equation or the other. Well, we know that this part was generated by the fact that, you know, anything cubed, any y possible in all of creation, has to be able to be formatted into this type of, you know, number. You can subtract 1 from y, get an a, and do that for anything. This, on the other hand, is something that we were just checking. Well, this proves that, no, this is not equal to y cubed ever, really. Y cubed cannot be in this format of a number. So, that equation, well, we can't make it exist, because if we find a z cubed and an x cubed, we'll never find a y cubed that'll fit. Alright, now you may say, okay, well that's all fantastic, and let me see if I have time for the second half. A few minutes. Alright. Now, you know, mathematicians will get pissed off at me and say, well, why don't you do the x plus n case? And I'm like, alright, fine, I will. And at that point, I've proven it for 1, I've proven it for n, and it's proven for everybody. Alright, if p equals 5, right? Here's the thing. X to the, or z to the 5th is going to be x to the 5th plus 5x squared, blah, 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 blah. And y to the 5th is going to be a to the 5th plus all the same stuff with an a instead of blah. You set them equal to each other, we do the exact same procedure. And we end up with this exact same situation, except instead of a 3, we're now at power of 5. And we, come to find out that all of a sudden a has to be, not only divisible by 5, but also by n, and also by x, or z, or, it's the same argument basically, that this thing over here, one of the factors, has to be in some way divisible by one of these two factors, and this stuff would have to be divisible by the rest of the stuff. This equation cannot exist. It cannot happen because a is always going to have to be divisible by, like I said, either x or z, which are both bigger than a. Because all the rest of the equation ends up being, this is all exactly the same as that, and then you're stuck with an a-fifth sticking in there. So that's the end of the explanation for that. Now, the whole reason why you can't have this is because you need, you always need p terms, as they say. Like x is a term and y is a term. If p is 3, you need, 3 things here. If p is 17, you would actually need 17 terms. And you can blame that on the fact that, for a dimension, see, like in the x squared case, everything makes a circle. The reason for that is because starting from the origin, you draw a chord. Imagine you drawing a chord taut, so that, the chord is always the same length, and it's tied to the x-axis. So basically, if you actually made this out of wood with a piece of string and like a little slidey knot over here, and something where you could drag the string around, there'd be a little hook over here, so you would drag this around, and you'd get your 3, 4, 5 value for, this would be 3 when this was 4, this would be 5 over here. And that's not quite right. But anyway, it comes out to something along the lines of, just plug values into the equation, you're going to get stuff that goes around this circle. The reason is it takes 2 coordinates to map out a point on that circle, to map out a point on that 2-dimensional shape. And, for p being higher, and like we know that for p equals 3, 3 cubed plus 4 cubed plus 5 cubed equals 6 cubed. I think that's right. I forgot to check it with a calculator before I started, but anyway, I think that's right. And that's the thing is, there's 3 terms because you need 3 coordinates to define a point in space. You have like that extra axis. So for each like dimension you're trying to show with z to the whatever, p power, that prime power is basically a dimension, and the number of terms is the number of coordinates you need to map something out in that dimension. Anyway, thank you.